We are going to do some calculation problems on asphalt volumetrics in practice in preparation for the exam. My name is Nathan Awad, and I am the asphalt engineer at the Indiana Department of Transportation. We are going to go over pages 6 and 7 of your classroom problems packet. These problems will help you become familiar with volumetric equations, and I strongly urge you to become familiar with these problems in anticipation of the exam, also so you can reference them in the exam as well. More information can also be found in Chapter 4 of the manual. Beginning at the top of page 6, we are going to look at the bulk specific gravity of compacted mixture using saturated surface dry specimens. Here's the equation for bulk specific gravity, also abbreviated GMV, and you can remember that as gravity of the mix bulk. A is weight of specimen in air, B is weight of surface dry specimen in air, C is weight of specimen in water. Let's pretend that we ran these tests in the lab, and we got these results for A, B, and C. Plugging these values into the equation would look like the following. We calculate the bulk specific gravity as 2.353. On the bottom of page 6, we are going to calculate the maximum specific gravity of compacted mixtures using saturated surface dry specimens. Here's the equation for the max specific gravity, often abbreviated GMM, or gravity of the mix max, where A is weight of the oven dry specimen in air, B is weight of container in water, and C is the weight of container and sample in water. Again, let's pretend we have run the test in the lab, and we got the following numbers for A, B, and C. Plugging these results into the equation would look like this. And we would calculate the GMM, the maximum specific gravity, as 2.451. Please make sure you understand bulk specific gravity and maximum specific gravity before moving on to page 7. Beginning at the top of page 7, we are going to start calculating volumetric properties. There are a few givens that we need to know that would either come from the mix design or other tests you have run in the lab. For these equations, the gravity of the aggregate is 2.609, the GSB, or gravity of the stone bulk. We know the percent binder, PB, is 6.6%, and the GMB and the GMM we just calculated. Now we're going to calculate percent air voids. Percent air voids uses the GMM and the GMB in this equation. Plugging in the values we already calculated would look like this. Don't forget to multiply by 100, and air voids in this case are 4.0%. Next, we are going to calculate VMA, voids in the mineral aggregate. This is the equation for VMA using GMB, percent stone, and aggregate GSB. Percent stone is a very simple calculation. It is 100 minus the percent binder. So percent stone is 93.4%. Using all these knowns, we plug them into the equation like so. Don't forget to take 100 100 minus the rest of the equation. VMA equals 15.8%. Next, we're going to calculate VBE. This is called volume of effective binder, or volume binder effective. VBE is a simple calculation of VMA minus air voids. We know VMA was 15.8 and air voids was 4.0. So VBE, volume of binder effective, is 11.8%. Next, we are going to calculate VFA, voids filled with asphalt. Here's the equation for voids filled with asphalt. Using all the knowns, the equation looks like this. And VFA is calculated to be 74.6. And in the testing world, VFA is often rounded to the nearest whole number. So in this case, VFA would be reported to be 75. Next, we are going to calculate density. In this case, we are going to calculate density in terms of pound per cubic foot. This is different than density as a percent of GMM. Density as a percent of GMM is what is typically used when calculating density of the roadway, such as 92%. In this case, we are going to calculate in pounds per cubic foot, which is often used in the paving process in relation to density gauges or nuclear gauges. So here's the equation for density. It is simply GMV, bulk specific gravity, times 62.416. The GMV is 2.353, and density would be calculated as 146.9 pounds per cubic foot. Next, we're going to calculate the effective specific gravity, or GSE, gravity of the stone effective. Here's the equation for effective specific gravity using percent binder and GMM. Using the givens we already have, the equation would look like this. And the effective specific gravity would calculate to be 2.716. Next, we are going to calculate percent binder absorbed, or PBA. It is a calculation using two aggregate properties, the gravity of the stone effective specific gravity, or the gravity of the stone bulk, the bulk specific gravity of the stone. Here's the equation for PBA. Plugging in the values we already know, the equation would look like this. Percent binder absorbed calculates as 1.6% of the binder is absorbed into the aggregate. Next, we are going to calculate percent binder effective, or PBE. PBE uses percent binder and percent binder absorbed to calculate how much is effective, or how much binder is left in the mix. Here's the equation for PBE. Please remember that percent stone is calculated as 93.4%. So PBE is calculated like so. And PBE equals 5.1%. 5.1% of the binder is effective in the mix, and is not absorbed into the stone. Next, we are going to calculate the dust to PBE ratio, also known as the dust to binder ratio. We need to know the amount of dust in the material. This is defined as the amount passing the number 200 sieve. This is either obtained from a test in the lab or from the mix design. We are going to assume the percent passing the 200 sieve is 5.3%. The dust to PBE ratio is simply dust over PBE. 5.3 divided by 5.1, which calculates to 1.0%. This is important because specifications require the dust to PBE ratio to be between 0.6% and 1.4%. We have practiced some of the typical asphalt volumetric equations and problems that you will see on the exam. I strongly encourage you to become familiar with these concepts, and you will be well prepared.